Afternoon all of you, and here is a problem from ellipse. An ellipse, a standard one with a more than b, an eccentricity of half with f1 and f2 as focus, and a is the top vertex. Let L be the line passing through f1 and perpendicular to a f2 intersects ellipse E at Q and R. If QR distance is 6, we need to find the perimeter of triangle AQR. Now I would ask you to give an honest attempt for this question, because after seeing solution everything will be easy, right? So before you see the video solutions, better you try it by yourself. Let's see how to do this. So in a general way, whenever we have any coordinate geometry problem, let's first draw a rough picture. So since we have the standard ellipse and with A is more than B, so it will be horizontal. So let's say we have focus f1 and f2, right? I'm taking f1 as right focus and f2 as left focus over here, and point A is the topmost vertex, which is 0, b. Eccentricity is known to me, half. What else is given? QR. So let's draw how to generate Q. So line L is passing through f1 and perpendicular to AF2. So we have line AF2 over here. Let's draw a line passing through f1 and perpendicular to AF2. This meets ellipse at Q and R, right? We need to find the perimeter of triangle AQR. So of course, with the given information of eccentricity, I can relate A and B. So B square equals A square into 1 minus C square, so 1 by 4. That gives 3A square over 4, right? So B and A is related. We are having one more relation of B and B with QR equal to 6. Okay, so now how to find QR? That's a challenge. But the idea of question is clear. With QR equal to 6, I'll be able to get one more relation that will give B and A. Once I know B and A, maybe I'll find a point of intersection of this line, Q and R. So line will be uniquely fixed probably by the given information. And then you can find the perimeter by distance formula. But going by this method will be quite traumatic experience, because it's going to be lengthy. So we'll use a smartness over here. Now what's the smartness? The smartness is E value. Since E equal to half forces, B a square equals 3a square by 4. So B gives root 3a by 2, right? Now what is B? Actually is this height. And what about the focus? So focus is A, will be A by 2. So we know focus is at a distance of A by 2. Similarly, F2 has a distance of A by 2. And this height B is root 3 by 2. So it feels very magically like this is an equilateral triangle, right? And we can clearly see with this given information, triangle A, F1 and F2 is an equilateral triangle. And since it is an equilateral triangle, so we have very special advantage over it. And we know line QR is 90 degree. Okay, so definitely it's angle bisector. Hence, this will also be same, right? So what I'm claiming now is, instead of AR, what if I reflect AR about this line QR? So AR will be F2R, right? These two will be same because of congruency. Similarly AQ, because in perimeter of triangle we need AQ. So AQ that will be same as F2Q because of the reflection. So I hope it is clear. Okay, so here let me redraw this diagram. So this distance is same as this distance, and we have new distance is same over this distance. And that's something really crazy, because instead of finding perimeter of AQR, which is AQ plus AR plus QR, now I can tell it is same as, since this distance AQ is same as F2Q, so I can write AQ as F2Q plus AR and plus QR, right? And now again AR can be written as F2Q plus AR distance is same as RF2, so F2R, and plus we have QR. And now you can clearly see what about this chunk of distance, like this plus this is equal to 2 times of A according to ellipse property. because sum of distance of a point from focus is constant, and that's 2a. So basically we have this plus this distance, again this plus this distance, and both is distance from focus. So this quantity becomes nothing but simply 4a. It's 2a plus 2a. Okay, so now the question is find the value for 4a. So just we need to find a, and that will solve the question. Till now I have not used the information of QR. So let's say how to use the focal length property over here. So we know in a standard ellipse, if an focal chord is inclined at an angle theta, so its length is given by 2b a square by a into 1 minus e a square cos square theta. This you can feel also by putting theta equal to 0, we'll get length of lattice, theta equals pi by 2, we'll get length of lattice rectum. In that case we'll have 2b a square by a, because this part will be missing, right? Okay. Moreover, it can be derived by taking a line passing through focus. So y minus 0 is slope m, which is tan theta, times x minus e. Okay, and try to solve this with ellipse. And to find this distance, basically we can just find point of intersection x1 y1 and x2 y2. There is no need to find this point of intersection actually, but basically you can find that distance by distance formula. So that will be x1 minus x2 whole square plus y2 minus y1 whole square. And since y2 minus y1 is nothing but m times x2 minus x1, so this formula reduces to mod of x2 minus x1 into root of 1 plus m square. Okay, and from the root of quadratic, by solving ellipse and lines, you can find the difference of root. Difference of root again is sum of root, so it's like a plus b whole square minus 4ab square root and times root over 1 plus m square. So this is what length will get. If you'll put the theta as the parameter with m as tan theta, you can derive this result very easily. Because sum of root will be known, product of root will be known from this quadratic expressions, and you can easily derive this. So that you can do by yourself. Now once you know length, I'll just put the value of L over here. So L is 6, since it's a focal chord, equals to b a square by a times 1 minus e value is half, so that goes to 1 by 4. Now what about the angle theta? Angle theta is also known surprisingly, because since this were equilateral triangles, so this semi-angle, this entire angle. Okay, so this angle was 60 degree, right? So what about the angle that the RQ makes, that this focal chord makes? It simply is 30. So this guy goes to 150, right? So this chord makes an angle of 150. तो यहाँ से cos of 150 will be cos 30 is root 3 by 2 minus root 3 by 2 whole square, so that's going to be 3 by 4. और यहाँ से जो वैल्यू आपका आएगा वो आ जाएगा 3 इक्वल्स बी ए स्क्वायर ओवर ए टाइम्स 1 माइनस 3 by 60. So we get 3 equals b a square by a times 16 over 13a, right? This value. Now what is b a square? Since I have already seen b a square equals 3a square by 4. So let's just put the value of b a square. So 3 into 13a equal to 16 times 3 by 4 a square. यहाँ से 3 gets cancelled. Okay, a gets cancelled and we are left with 4a equals 13. And now what we need to find is just 4a. That's the perimeter of the triangle asked. So the answer for this problem is 13. So I hope you have enjoyed the problem, and the takeaway of the problem was how the idea of eccentricity helps us to recognize the triangle being regular or equilateral triangle. And using that, I use the symmetricity about the line PQ. Once we have harnessed the property of ellipse, very basic property of ellipse, sum of distance from focal chord from any point to the focus, sum of distance equals constant, and that's 2a, which is length of major axis of ellipse. और फिर PQ का भी यूज़ कर लिया, ठीक है, ये डिस्टेंस का यूज़ कर लिया. If you already know this ready-made formula of 2b square by a into 1 minus e square cos square theta, it saves you time. If you don't know, so at least you should be acquainted with the procedure. Okay, so you can't afford thinking procedure in the examination. This would be ready made to you in your 2 years of learning program.